Hi everyone, this is your homework assignment for Monday, March 6th. This is about using mean absolute deviation and what it actually entails. In this video, I'm going to go over again with you how to calculate the mean absolute deviation of a data set, as well as show you some different ways in which to organize it. Once that has been done, you will have a homework assignment that has a few more questions than what you've been receiving because you need the practice, and I want you to really explore this information. Altogether, focus, this should take you about, I would say, 25 to 30 minutes to complete this activity. Let's do a quick review of what the definition of MAD is. Remember that MAD is the average distance between the mean and each data point. A small MAD shows that your data is closely huddled together. A large MAD means your data is spread out. Here's an example of two hypothetical students, student A and student B. I've used dot plots to represent the data, but the difference in these dot plots as compared to the previous one is that the data, it has intervals spread out in equitable chunks of 10. You can see that here and down here. Now, if you look at the data that is shown for student A, you will see that a lot of information has been huddled in this section, and then you have 3 outlier points over here. That's for student A. Student B, on the other hand, that person's data is spread out all across the graph. That shows, without having to calculate any MAD whatsoever, like actual numbers, that student A is going to have a much smaller MAD than student B. This is because student A's data was closely huddled together and student B's was spread out all over the place. Here's another example. We're going to call this person student C. This is a hypothetical IXL performance. And in this, you see 2 highly clustered data points. You have 11 zeros, because this student did not do a lot of assignments, and you've got 11 80s. The median score is in between the 3rd and the 4th dot on the 80 side. That's huge because if you calculate the mean, it's 53.8. That is a huge difference between the median and the mean. On this, I've created a MAD matrix, which will be an easy way for you to calculate exactly what the mean absolute deviation is. In step 1, I recorded each data point once. That was from the previous line plot I just showed you on the previous slide. On second step, I subtracted the mean, which I had found was 53.9, because I rounded up, from the data points one time. That is represented by this row of green numbers here. Then in purple, what I did is I counted how many times each data point repeated itself. For example, there were 11 zeros and 11 scores of 80. So by doing that, I multiplied the 53.9, remember I'm using absolute value here, and I multiplied it by 11, giving me a total of 592 and 9/10. The reason I did that is to save me the step of just writing number after number after number out like you may have seen before. Once I've done that, I then added all of these numbers together and divided by 34 again. I divided by 34 because I had 34 data points. This gave me a mean absolute deviation of 35. That is huge, but that totally makes sense because if you look at the previous slide, you will see that the data was spread out pretty much a lot in between the 0 and that 80, and then there were some data points that were in between. Okay, you have 10 questions. It says use the following information to answer questions 1 through 10. 20 words were randomly selected from a 4th grade science book. The following list shows the number of letters in each of the 20 words. So the numbers that you see here in this column show the page, the number of letters, and the 20 words from this 4th grade textbook. And underneath it, you see something very comparable to that, except it's for 7th grade. You're going to be comparing these two data sets back and forth in your questions. In number 1, you're being asked, what is the mean word length of words in the sample from the 4th grade textbook? In number 2, you're being asked, what is the word length of words in the sample from the 7th grade textbook? In questions 3 and 4, you're being asked to calculate the mean absolute deviation, except the question number 3, this is about the 4th grade, and in question 4, it's about the 7th grade. Question 5 is how much greater is the mean word length in the sample from the 7th grade textbook than the mean word length in the sample from the 4th grade textbook. So you're being asked to compare the MADs from the 4th and the 7th grade textbook samples. In question 6, how do the word lengths compare between the 7th grade textbook and the 4th grade textbook? Question 6 and question 5 are very similar. 6 is more of an opinion question because you're being asked to show how much they compare. Question 7, what conclusions can you draw about the mean word length of all 7th grade science textbooks compared to all 4th grade science textbooks? Basically, they're looking to see if you see a pattern and how the words and how the length of those words change. Question 8 says, what can you say about the variability in the length of words in the 7th grade textbook compared to the 4th grade textbook? Variability means how much it changes over time. If something has a high variability, that means it changes a lot. If it's a low variability, that means it doesn't change very much at all. In this question, you can ignore questions 9 and 10 unless you want to get extra credit. So questions 9 and 10 are extra credit. This can give you a 50% bonus on this homework assignment. Please be prepared to have this on Monday morning. Thanks.